Welcome back, everyone. Today we're going to learn something very powerful. Dynamic data source creation in Spring Boot. In the last few videos, we learned master-slave routing, where data sources were known upfront and configured at application startup. But in real-world systems, that's often not enough. Imagine a multi-tenant application, where new tenants can be added while the application is already running. Each tenant might have its own database or share a database but with different credentials. And the key challenge is this. How do we create and manage data sources dynamically at runtime? That's exactly what we're going to learn in this video. We'll see how to create a data source on the fly, how to register it dynamically, and how the application starts using it without restart. In this video, we're again going to use the concept of a routing data source. So if you haven't watched the master-slave routing video, I strongly recommend you watch that first. Because the core idea, how routing works and how Spring decides which data source to use, is exactly the same here. The only difference is that this time, instead of having fixed data sources at startup, we'll be creating data sources dynamically at runtime. Once you understand the master-slave example, this dynamic data source approach will be much easier to follow. Alright, let me explain the setup first. Just look at my screen. I've already created a dynamic data source project. And just like our previous projects, it's structured into two modules: API and DAO. The dependencies are exactly the same as the last video, so I'm assuming you're already familiar with that setup. Now, let's talk about the database design. This part is very important. I have two types of tables here. First, an employee table. This table will exist inside each tenant's database. Second, a table called tenant_db_config_detail. This table lives in a master database, and its job is to store tenant-specific database configuration. For example, for each tenant, this table will store things like tenant ID, database URL, username, password, any other configuration you need. The idea is simple. When a new tenant is on board, we create a new database for that tenant, and that database contains the employee table. At the same time, we insert an entry into the master database inside tenant_db_config_detail, so the application knows how to connect to that tenant's database. Later, at runtime, our application will read tenant details from this master table, create a data source dynamically, and start using it without restarting the application. Alright, let's start by creating the database and tables for our setup. First, we'll create the master database. This database is very important. It will store tenant configuration details, like database URL, username, password, and other connection info. Next, create a dedicated database user for it. And grant the required permissions. Alright, the master database is created, and the database user with proper permissions is also set up. Alright, Now let's connect this master database using dbeaver. Next, let's create a tenant database. For this demo, you can assume that one tenant database is already present. Follow my screen. Alright, the Tenant1 database is created. Now let's connect to this database using our database client. Alright, let's open the SQL editor for the master database. Now, inside the master database, let's create a table called tenant_db_config_detail. OK. Created. This table will store all the tenant-specific database configuration, like which database belongs to which tenant, and how our application should connect to it. Alright, so right now this table is completely empty. And since we've already created Tenant1, let's go ahead and add its configuration details here. As you can see on my screen, there are a few Hikari CP configuration options here, like max pool size, connection timeout, and so on. These settings are very useful in production environments, where you need fine-grained control over connection pooling. But for this demo, I'm going to keep things simple. and just use the default Hikari settings. So I'm not explicitly configuring them right now. Later, when you move this to production, you can always tune these values based on your load and traffic. Alright, the Tenant 1 configuration details are inserted successfully into the master table. Next, let's open the SQL editor for the Tenant 1 database. Now, inside the Tenant 1 database, let's create the employee table. This table will store all employee data for this tenant. Alright, now let's move to the code side. The first entity we're going to create is tenant dbconfig detail. This entity will map to the master database table. That stores all tenant database configuration, like database URL, username, password, and other detail. This entity is very important, because our application will read from this table to create data sources dynamically at runtime. Next, we need to create the employee entity. We've already created this entity multiple times in our previous videos, so there's nothing new here. To save time, I'm simply going to copy it from the last project. Alright, next we need a way to identify which tenant the current request belongs to. For that, we'll create something called a tenant context holder. This class will use threadLocal to store the current tenant ID for each request before any database operation starts. We'll set the tenant ID in this context. And later, when our routing data source is triggered, it will read the tenant ID from here and decide which tenant data source to use. Since every request runs on its own thread, thread local ensures tenant information stays isolated and safe per request. Inside tenant context holder, the first thing we'll do is create a thread local object. This will hold the tenant ID for the current request. Next, create a set method to store the tenant ID in the thread local. Then we'll add a get method to retrieve the tenant ID whenever we need it. And finally, we'll add a clear method to remove the tenant ID once the request is completed. Alright, next we're going to create the core class for this feature. Dynamic Tenant Routing Data Source. This class will extend abstract routing data source exactly the same way we did in the master-slave routing example. The only difference is the routing key. Earlier, we routed based on database type, master or slave. This time, we'll route based on the tenant ID. Alright, now let's extend this class with abstract routing data source. Need to implement one required method. Determine current lookup key. This method is called by Spring every time. It needs to decide which data source to use. In our case, the routing key is the tenant ID. Fetch the tenant ID from tenant context holder and return it. Whatever tenant ID we return here, Spring will use that as a key to pick the correct tenant data source. Now, here's an important part. We need a place to store data sources for each tenant once they're created. For that, I'm going to create a concurrent map. The key will be the tenant ID, and the value will be the corresponding data source. Alright, next we'll add a helper method here called add tenant data source. Take two parameters, the tenant ID and the corresponding data source. Inside this method, the first thing we'll do is put this data source into our concurrent map, using the tenant ID as the key. After that, we need to inform Spring that a new data source has been added at runtime. For that, we'll call setTargetDataSources and pass the updated map. And finally, we'll call afterPropertiesSet. This step is very important. AfterPropertiesSet tells Spring, hey, the routing configuration has changed. Please reinitialize and pick up the new data sources. Without this call, Spring would not be aware of the newly added tenant data source. So this method is what allows us to add new tenant data sources dynamically at runtime, without restarting the application. Next, we'll add one more small helper method here. Is tenant data source present? The purpose of this method is very simple. Before creating a new data source for a tenant, we want to check whether it already exists or not. Alright, that's done. We've completed the routing data source logic here. We can now check if a tenant data source already exists, and dynamically add a new one when required. This is the core foundation for dynamic, runtime multi-tenancy. Now let's move on to the next piece. Alright, next we need a way to actually create a data source object when a new tenant comes in. Remember, this data source is not created by Spring automatically. We have to build it manually and populate all the configuration ourselves, like URL, username, password, driver class, and pool settings. To keep things clean and reusable, we'll create a separate helper class called DataSourceFactory. This class will have the responsibility of creating a data source, applying all configuration values, and returning a fully initialized data source instance. Let's add a method called createDataSource. Take tenant config db detail parameter. For creating the data source, I'm going to use Hikari config. As you can see on my screen, Hikari config provides all the required setter methods. We can configure things like the JDBC URL, username and password, maximum pool size, connection timeout, and other pooling-related settings. This gives us full control over how each tenant's data source is configured, completely programmatically. First, set the JDBC URL here. Next, set the username for this data source. Next, set the password. After that, set the driver class name, so Hikari knows which JDBC driver to use. You'll also notice that we can set things like maximum pool size, connection timeout, and other tuning parameters here as well. These are very important in production environments, where performance and resource usage really matter. But for this demo, I'm going to stick with the default Hikari settings, so I'm not explicitly configuring them right now. Giving each tenant a unique pool name. Now the final step here. We'll create a Hikari data source. by passing this Hikari config object to it. Alright, that's done. Alright, before we move forward with creating tenant-specific data sources, there's one very important thing we need to do first. We need to configure the master database. Why? Because all the tenant database configuration details are stored in the master database. So before we can dynamically create tenant data sources, our application must be able to connect to the master DB and read tenant details from it. Create master DB config class. First thing we're going to create is the master database data source bean. Alright, now let's add the master database configuration in our application.yml. To save time, I'm just going to copy this configuration from our old project, instead of typing everything again. I'm just updating the required details here, like the database URL, username, and password, to match our master database setup. Now, to access the master database, you have two options. You can use JPA or JDBC template. Personally, in many real-world projects, I prefer JDBC template here, because it gives a bit more control and simplicity when reading configuration tables. But for this demo, I'm going to use JPA. So since we're using JPA, we need to create the required JPA beans for the master database. The first one is the Local Container Entity Manager Factory bean. Alright, let's create the Local Container Entity Manager Factory bean object. Next, set the data source. After that, I'll set the entity package to scan. One important thing to note here. Earlier, both employee and tenant config DB detail entities were in the same package. To keep things clean and avoid confusion, I've now separated these entities into different packages. One package for tenant configuration entities, master DB. Another package for employee entities, tenant DB. Next, set the persistence unit name. Alright, next we need to create the transaction manager for the master database. Alright, that's done. Our master database configuration is now complete. Alright, next we need to enable the JPA repository for the master database. Next, we'll enable transaction management. Alright, next let's create the tenant config detail repository. This repository will talk to the master database and fetch tenant configuration details from the tenant_db_config_detail table. Alright, now comes the most important part of this video. Next, we need to load tenant configuration from the database and create data sources dynamically based on that data. So let me clearly explain what we're going to do here. We'll handle tenant data sources in two phases. First phase, at application startup. When the server starts, I'll load all tenant configurations that already exist in the master database. For each of those tenants, we'll create the data source up front and register it inside our dynamic tenant routing data source. This ensures that existing tenants are ready to serve traffic immediately. Second phase, at runtime. If a new tenant is added while the application is running, we won't restart the server. Instead, when the first request for that tenant comes in, we'll fetch its configuration from the master DB, check whether a data source already exists, and if not, create it dynamically and add it to the routing data source. This means you can choose both approaches: eager loading at startup, what we're doing here, or lazy loading on first request. Alright, now create a new class called Tenant Initializer. This class will be responsible for initializing tenant data sources. Inside Tenant Initializer, we need access to a few important components. First, we need the tenant config detail repository to fetch tenant configuration details from the master database. Second, we need DataSource factory. This factory is responsible for creating the actual DataSource objects based on tenant configuration details. Third, we need the dynamic tenant routing data source, because this is where we'll register all tenant-specific data sources. I'm using a post construct here to load all existing tenants from the database, create their data sources, and register them in our routing data source. Alright, the first thing we'll do load all tenant database configurations from the master database. Now, for each tenant we get from the master database, we'll do simple things. First, we'll create a data source using the tenant's configuration. Second, we'll register that data source inside our dynamic tenant routing data source. Alright, that part is done. Now let's handle the second scenario: runtime tenant registration. Create another helper method called initialize tenant if not present. Take the tenant ID as a parameter. Check whether a data source already exists for that tenant. Do nothing. Now comes a very important part. We need to make this logic thread safe. Remember, in a real system, multiple requests for the same tenant can arrive at the same time. Inside this synchronized block, we'll check once again whether the tenant data source is already created. Next, fetch the tenant configuration. If not found, then throw exception. Next, create the data source using our data source factory. After that, register this data source inside our dynamic tenant routing data source. Alright, that part is done. Now we're moving to a very important step. We need to expose our dynamic tenant routing data source as a Spring Bean. Alright, next we need to create the tenant DB configuration. Alright, let's create a new configuration class for this. Next, create the data source bean. But here's the important part. For tenants, we're not going to use a normal data source. Instead, we'll use our dynamic tenant routing data source. This routing data source will act as the single data source for the entire application. At this point, you have a choice. On top of this routing data source, you can use either JDBC template or JPA. Both approaches work perfectly fine. If you want more control and very fine-grained SQL handling, JDBC template is a great option. But for this demo, I'm going to go with JPA. To save some time here, I'm just copying and pasting the configuration code from our master DB config. Now I'm just modifying the required parts here. Alright, now the last thing we need to do in this configuration is enable JPA repositories and transaction management. Alright, that's it. All the dynamic data source configuration is now complete. Alright, next let's create the employee repository. Alright, next let's create the employee controller. Inject the employee repository. Alright, now let's create the Add Employee API. Alright, next let's create the Get Employee API. Alright, so the APIs are done. But there's one important problem we need to solve. Every time an API is called, we need to make sure that the tenant is identified and the tenant data source is already loaded or initialized if it's not present. Now, technically, we could write this logic inside every API method, but that would mean duplicated code, messy controllers, and a very bad design, especially when you have multiple APIs. You definitely don't want to repeat the same tenant check logic again and again. So instead, we'll use a Spring Boot filter. This filter will run before every request. Extract the tenant ID, initialize the tenant data source if required, and set the tenant context. That way, by the time the request reaches the controller, everything is already prepared. I'll explain filters in much more detail in a separate video. For now, just follow my screen. And let's implement. Alright, now let's create a new filter called Tenant Filter. Extend once per request filter. This filter will run before every HTTP request and take care of all tenant-related setup for us. Implement the required method. Do filter internal. This method gives us access to HTTP servlet request, HTTP servlet response, which means we can read headers, identify the tenant, and prepare everything before the controller is called. So here's the expectation. The tenant ID will come in the request header. Inside this filter, the first thing we'll do is read the tenant ID from the header. You can name this header anything you want. For example, xTenant ID. Let me read the tenant ID from the header now. Just follow my screen. If the tenant ID is null or blank, you might return a detailed error response with a proper error code and message. But to keep this demo simple, I'm just returning a 400 bad request from here. Next, I'll inject the required dependency here, the tenant initializer. Now that we have the tenant ID, the next step is to initialize the tenant data source if required. So I'll call initializeTenantIfNotPresent method here. Next, we'll set the tenant ID in the tenant context holder. This is very important because our dynamic tenant routing data source reads the tenant ID from here to decide which data source to use. Now that everything is set up, we can continue the filter chain. And finally, in a finally block, we'll clear the tenant context. Alright, everything is almost done now. All the configuration is in place. Dynamic data source, routing, tenant filter, everything. Let's start the application and see what happens. Alright, we're getting an error here. It says provider class is not set. That usually means one thing. We forgot to configure the JPA vendor. In our case, Hibernate. Let's go back to our JPA configuration and double check this. Yep, found it. I forgot to set the JPA vendor adapter here. That's why Hibernate wasn't getting picked up. Let me quickly add the Hibernate JPA vendor adapter and set it on the Entity Manager factory. And there's one more thing. We copied this configuration into the tenant DB config as well. So the same fix is required there too. Alright, let's start the application again and see what happens now. Alright, let me explain what actually happened here. I debugged this offline, and the issue is now clear. When we use JPA, Spring tries to initialize the Entity Manager factory at startup. During this initialization, JPA expects the data source to be ready immediately and tries to get a connection. But in our case, we're using a dynamic tenant routing data source, and at startup time, no tenant is set yet. That means determine current lookup key returns null, and there is no default data source configured. So JPA fails with a connection-related error. To fix this, we must set a default data source on the dynamic tenant routing data source. This default data source is only used during application startup or when no tenant is set. Once the request comes in and the tenant is resolved, routing works exactly as expected. Now, one important note. If you are using JDBC template, you usually won't face this issue, because JDBC template does not eagerly initialize connections the way JPA does. This behavior is specific to JPA. Just follow my screen. Start the application again. Alright, we're getting one more error now. This one is a column mismatch error in the entity. That simply means our entity fields don't perfectly match the table columns in the database. I'll quickly fix this by adding the missing column mapping in the entity. Alright, let's start the application again. Alright, we're getting another error related to the Entity Manager factory. I can already see the issue. I copied this configuration from the master DB config, and I forgot to remove the @primary annotation. Because of that, Spring is getting confused about which Entity Manager factory should be treated as the default. Start the application again. Wow! It finally started this time. The application is up and running successfully. All the configuration issues are resolved. And our dynamic tenant data source setup is now live. Alright, now let's test the API. First, I'm going to hit the get API without sending the tenant ID in the header. And as expected, we got a 400 bad request. Alright, now let's send the same request again. But this time with tenant 1 in the request header. As you can see, we got an empty list. And that's totally expected. The request is now correctly routed to the tenant 1 database. But tenant 1 doesn't have any employee data yet. Alright, now let's add some employees for tenant 1. Nice. We got a success response. Let me add one more employee for tenant 1. Perfect. We got a success response again. Now let's verify this directly in the database. And as you can see on my screen, both employees are present in the table. This confirms that our dynamic data source routing is working exactly as expected, and data is getting stored in the correct tenant database. Now, this is the most interesting part. And please notice this carefully. I'm not stopping the application. The application is still running. And now, while it's running, I'm going to add a new tenant, tenant 2, into our system. This is exactly the problem dynamic data source is meant to solve. Let me add tenant 2 now. Just follow my screen. Alright, the Tenant2 database is created. Now let's quickly create the employee table. Inside this Tenant2 database. Alright, the Tenant2 database and employee table are ready. Now I'm going to insert Tenant2's configuration into the master table. And please notice this carefully. The application is still running. I'm not restarting anything. This insert is happening while the server is live. Alright, that's done. The Tenant2 configuration is now inserted into the master database. Alright, now I'm hitting the Get API with Tenant2 in the header. And as you can see, we're getting an empty response. It means the application was able to read the Tenant2 configuration from the master database, dynamically create the Tenant2 DataSource at runtime, and successfully connect to the Tenant2 database. If the connection was not working, we would have seen a 400 or some database error. Now let's hit the same Get API, but this time with Tenant1 in the header. This will help us verify tenant isolation. Each tenant should only see its own data. And look at this. When we hit the API with Tenant1, we get only Tenant1's employees, Rahul and Pankaj. Tenant2's data is completely isolated, and Tenant1 cannot see it at all. Alright, now let's add some data for Tenant2 as well. Let's also add some more data for Tenant1. Now let's verify this directly from the database. And as you can see on my screen, the Tenant1 database now contains all the newly added Tenant1 data. Now let's check Tenant2 as well. And as you can see, the Tenant2 database contains only Tenant2's data. There's no overlap, no mixing. Complete isolation between tenants. Alright, now let's hit the Get API one more time, but with Tenant1 in the header. And there you go. As you can see on my screen, when we hit the Get API with Tenant1, it returns only Tenant1's employees, Rahul, Pankaj, and Rohit. This is exactly what we expected. Alright, now let's do the same thing for Tenant2. Perfect, look at this. When we hit the Get API with Tenant2, the response contains only Tenant2's employees, Rock and John. This is exactly the behavior we were aiming for. Now, before we wrap this up, there's one very important internal detail that I want to highlight, especially if you're thinking about using this approach in production. If you look closely at our implementation, every time a new tenant data source is added, we are calling afterProperties_set on abstract routing data source. What does this actually do internally? Inside abstract routing data source, Spring maintains an internal resolved data source map. When we call set target data sources, followed by after properties set. Spring rebuilds that entire internal map again. That means existing data sources are reprocessed. The map is recreated. References are recalculated. And when this happens frequently at runtime, especially when tenants are added dynamically, this can become a problem in production systems. In low traffic or demo environments, you probably won't notice anything. But in a real production system with high concurrency, multiple threads, frequent tenant onboarding, repeatedly rebuilding the internal routing map can lead to performance overhead, thread safety concerns, unexpected behavior under load. So this approach works, but it's not the most optimal design for large-scale systems. A better production-grade approach is to write your own custom routing logic, instead of relying on abstract routing DataSource internal map rebuild. Alright, that's it for this video. I hope this helped you understand dynamic DataSource routing and multi-tenancy in Spring Boot in a clear and practical way. If you found this useful, please hit the like button, subscribe to the channel, and drop a comment below if you have any questions or suggestions for the next video. Thanks for watching, and I'll see you in the next one.